So there are some courses that you will start taking next semester. I think programming concepts, and then so the other way to get connected with the department is through the student groups. Right? So that's why you have this going on, so that you get connected with the seniors. Try to see if you can start forming the seniors you can sort of refer to, and so on. What we have today for you is a selection of talks of, I think, more research related. Shaun, are you going to talk about? Yeah, so you're going to see some of the top-notch research that's going on in the department. And one of the things in REU, you are going to sort of see how knowledge is being created in computer science. What are the technologies you are working on? Right? That you're going to see market in probably 10 years. Right? So that's something that you should always try to get involved in REU activities as soon as you can. So with that, I would, who wants to talk next? Okay,
that is
me.
all right. So, hey everyone, my name is Schinnel Small. I am representing Dr. Jing Wang, who could not be here. And I wanted to talk to you about an opportunity that isn't quite as research intensive, but it is a really great opportunity for you guys to connect with each other and to understand what we in computer science and engineering are doing to make computer science more open and inclusive to everyone. So I'm going to talk to you really briefly about broadening participation in computing and what our department is doing to help with that effort. So what exactly is BPC? BPC is short for Broadening Participation in Computing. It represents our department's commitment to ensure that computer science is available and accessible to people of all diverse backgrounds. In particular, we are trying to increase enrollment of women and underrepresented minorities in computer science and engineering. But if you don't fit that exact demographic, you don't have to worry, because we cannot have inclusion without all of you. Okay, so our purpose with our BPC effort is to really ensure that the students that graduate after getting through our courses and matriculating at USF is more representative of the type of environment that they will be going into in the industry. We also want to make sure that the industry recognizes that computer scientists consist of all races, all creeds, all backgrounds, all nationalities, because we will need all of these people to help us solve the bigger problems out there. So the initiatives that we use in our department include some evidence-based practices as well as some other activities that can help to make our classrooms hopefully a little bit more welcoming than the way that computer science classrooms have been perceived before. So some of the evidence-based practices include things like peer-led instruction, where we may ask, well, not a classmate, a current classmate, but a former classmate to help you with sessions if you're having problems with any kind of coding, if you need advice on where to go to properly look for resources. Remember I said Stack Overflow or anything like that, you're not ready for that yet. Right, but we have peer-led instructions that can help students, right? Some classes will implement peer programming. A lot of our classes that you see here, and those are the introductory classes, they will do proactive advising. So we try to ensure that you're on track by having steps along the way where we contact you to make sure we know how you're doing, we know what is happening, what missteps you're having, where you'd like to see improvement. These are things that we do to ensure that you remain engaged in our courses. And we are also working on trying to have more activities that involve social computing, where we give you the opportunity to work on projects that are a little bit more relevant to society, as well as a little bit more reflective of some of the things you may encounter in research as you matriculate at USF. Okay? There are other BPC activities that you may be interested in. One of our efforts is that we try to engage the faculty, the staff, and the students in workshops to help promote diversity and inclusion, right? We try to sponsor students every year to attend the Grace Hopper and Tapia events. I think, and I did ask, unfortunately, I think we may have closed that window for Grace Hopper this year, but Grace Hopper next year, it's a good opportunity, so you may want to keep that in the back burner. So we highly encourage students to get involved with us, and if you're interested in any of these particular conferences, reach out to us and we'll try our best to sponsor you so you can attend these once-in-a-lifetime events. And these are usually really good events, and there are a lot of good opportunities for you to meet with some big tech companies like Google, Microsoft, Facebook. Yeah, they're usually there. There are a couple gaming companies as well. I can't list them all. There's really a whole bunch of them. Okay, so in addition to that, we have other BPC activities where we try to use some of our students to help with our diversity and inclusion initiatives. You may have seen two of them in the massive crowd out there, Daria and Chloe. So Daria is, this is Daria. She is one of our student ambassadors. Chloe is another one of our student ambassadors. They're currently working really hard out there trying to get people checked in. So be nice to them, tell them that you saw them on the presentation, and tell them that, hey, Dr. Small says hi if I don't see them in that crowd. But one of the nice things about the CFC student ambassadors is that they do an even better job at promoting computer science to people of all diverse backgrounds. And it just so happens that we are looking for some new student ambassadors to help her out because, two students with that, they might need a little bit of help. So, if you're interested and, you have a great personality and you want to share your talents with the world and help us promote our aim here, give us a call. In fact, I'll do you one better. What you need to do is you need to talk to our success coach who might be right outside the door and therefore I cannot get her attention. We have a success coach in our department now, and she is awesome at helping you maintain your path for success in computer science and engineering. And she will also be helping us increase our student ambassadors. So back to what I was saying, if this is something you might be interested in, you definitely want to check out our success coach, Jasmine, who might be outside the door, right? She's awesome, and hopefully we'll get a chance to introduce her later on. And we also have several student groups that are directly involved in our BPC initiative. The two major ones who are setting up outside, definitely go check them out, is WIGC and Girls Who Code. Dr. Wang is the faculty advisor for WIGC. I'm the faculty advisor for Girls Who Code. And I just want to make it clear, despite the names of the groups, the emphasis of women and girls, we are open to all members, right, of the student body, right? So we do not have any kind of restrictions. We welcome you all, and we look forward to your participation in these groups, as well as any other groups you may be interested in, and you'll definitely get a chance to check them out. I promise we're going to keep you in here all the time. Okay? Right? One last thing that I do want to mention before I pass it on to the next is that we actually have a website. The current site like this, you can access at usf.edu. You can just click on you'll see a link that's inclusion. So you can click on the inclusion link so you can get to this information. We are currently in the midst of updating it, so pardon the current interface as we try to make it a little more scrollable and interactive and a little less clickable and so forth. But we definitely invite you guys to come back and ideas that you may have with our initiative. So that's all I have. And I think we're out to 10. What I'm going to do is I'm going to pass along to Sriram, who will talk to you about this.
He gave me the toughest follow-up. very, very hard to follow. Your energy. Especially that I did for the last 60 hours. I just flew right from India, so I'm a little jet lagged and all that. Anyway, so I intended this to be a research presentation, but after seeing it, I was just thinking how I can get this more contemporary level. So this is the title of my presentation. So I'll get a little bit of the history here, okay? So I want to get home what I said, while computer science, computer engineering, cybersecurity, these are all algorithms, hardware, coding, data structures, databases, etc. The impact of your degree is significant, is far-reaching. Okay, that's the take-home message I want to give you here. So, what 2016 Zika hit Florida, delivered a baby. I was kind of okay, but my neighbor mosquito bit. This story, Shaun. The mosquito bit my neighbor. She was pregnant, and she came and said, "Oh, I got pregnant after so long. I just wish somebody had told me if it's with Zika." Very casual, talk. And then coming from tropical part of the world, that mosquito-borne disease is very common. I thought it's an interesting problem. Okay, so then I just went to the Hillsborough County mosquito district. I said, I showed my USF card and said, "Teach me about the Zika. Okay, it's really annoying that an insect like that can create so much." Right? The women, when they deliver babies, sometimes the baby's head has encephalitis, not a pleasant sight. I'm sure some of you remember. And then they told me some of the main challenges of mosquito diseases. And guess what? Based on my understanding, I now know this field for about 6 years. Maybe 60–70% of the problems they face in combating mosquito diseases can actually be solved by computer science and engineering. Okay, I realized that, and then I told them, look, these are things we can do with computer science and AI. And they were like, really? Let's collaborate. And then I made a lot of good collaborations. And then I'll show you exactly where I am right now. Okay? So the main thing that I found out was that there are about 4,500 types of mosquitoes in the world. That many species are there. Of 5 or 6 diseases. Okay? Out of 4,500 mosquitoes, only 5 or 6 diseases. And maybe some of you might not know, only the mosquito spreads diseases. Because only the female mosquito drinks to make proteins for its babies. Male mosquitoes feed on plant next to it, bite. So the mosquito bites, it's a female mosquito, and it's mainly because it wants to deliver babies. That's why it's biting. There's no other reason for it to bite anybody else. Okay. Out of these 7 or 8, only a few actually bite humans. The rest mostly bite birds and other animals. Okay. So finding these mosquito species in an area is very important. But how do they go trap mosquitoes? Thousands get trapped. Sometimes they bring them to the lab. They look at one by one with a microscope. Look for a very specific marker, okay? And then they make a note saying, yes, it's this vector. Vector is something that's distances. This is not a vector mosquito. Then they count the vectors. Then they do for staying like that. They find many vectors in an area. Then they go spraying. Okay. Sometimes a citizen calls and says, I have a bunch of mosquitoes in my home. Another citizen calls somewhere else. By citizen, I mean person. Okay. I just use the word citizen science. So then they don't know where to prioritize. That was a big challenge in Zika. Everybody started calling, I have mosquitoes in my backyard. So they didn't know where to go and spray pesticides to kill the mosquitoes. Okay, if they had citizens, I told them, this is a picture of the mosquito. Okay, and AI take this is the vector. The vector is Aedes aegypti. That's one of the deadliest vectors. Spread Zika, dengue, chikungunya, and yellow fever. Okay, if the people know that this was Aedes aegypti mosquito, then the city can know where to prioritize. But the citizens cannot be able to do that, but they can take a picture of the mosquito, take a picture, send it to the Department of Public Health. They can make this automatic analysis, and then they can build a quick real-time database, and then they can say, this area has too many of these. We need to go spray that, okay? And especially if that area is abandoned fires, it's even more important, right? Because that mosquito lays eggs primarily in fires. Okay? That's why they spread a lot in Florida, a lot of abandoned areas in Florida. So overall goal of our project was we got some $1 million from the federal government. It's the citizens who basically take pictures and also report dead birds and take pictures of fires with water. And then they give us this data. We use AI to identify the genus and the species of mosquito. We have technology that can also by looking at the size, the shape, and the color of the abdomen. That's also important because the more they see this vector bring blood, then they know that there is a public health crisis in that area soon. We want to use data mining techniques to build risk groups. Counties in the state of Florida and even in the US, the public control, the mosquito control has to happen. And the mosquito control with the public education, and we're also building apps. Okay, and the overall goal is to cure vector mosquitoes and more engaged business. So this is kind of not too important. Some papers we published in this field. So we have these mosquito vectors. I talked about this. We did a project in Uganda where you can fly drones, and then the drone will capture images of the surface, and then the AI will identify where exactly there is mosquito larva. So that immediately the GPS coordinates will be given to the village chieftain, and he will mobilize a bunch of people to move over those sources of water. Why? Because pesticides are not good. Mosquitoes develop resistance to pesticides. But it becomes soil over them, then the larvae cannot breed anymore. Okay, so you actually kill the mosquito before they become adult. And this is another work we did that we taking has big impact. By taking a picture of a mosquito, we can extract the wing of the mosquito. Why this is full? We can tell a citizen, a person saying that if you see this symbol in a wing, that's a vector mosquito. So interested people can be at home and learn how to. And so here is the training data. All of these are related. And then this is automatically as the drone flies, we run these artificial intelligence algorithms that can put a boundary box around places where larva is detected. And these GPS coordinates, like I said, will be fed to the public real time, and they actually go and dump. So this is a going project in Uganda. Maybe we are the first people to do something like this in the world. This is the other work they said, where given an image of a mosquito, you can extract the anatomical components. And again, this is a very interesting project, right? Why? Because of COVID, what happened was across the world, especially in countries like India and Africa, the mosquito surveillance budget was cut down. Okay, so all the mosquitoes that were in the lab for people to identify, there was no AC, there was no maintenance. So now people have to again go and trap those mosquitoes, bring them back to the training process. The technologies like this, you can digitize basically the whole identification process. Have a bunch of wings of vectors, abdomen, legs, have a bunch for non-vectors, and then seeing the entomologist can actually train so that they don't lose the. See what I'm saying, right? Yeah. So we are trying to commercialize technology. There's some interest from the CDC, we'll see how it goes. And then realize that there's so much you can depend on the public. So we built this smart app at USF. I just finished completion, maybe 2 or 3 months ago. We are now trying to test it. And what this trap does is, it attracts mosquitoes, and when the mosquito goes into the trap, it gets stuck to a piece of paper. There's a camera that will take a picture, and then it will identify in real time if it's a vector. There is one that's been, and it will identify if the mosquito has consumed blood, and if you're lucky, it can identify if the mosquito is pregnant or not pregnant. Actually, it doesn't have eggs and spill. We can identify even that. And we are trying to do this trap, so that and then the public health officials in real time tap this off in emergency. It will be for mosquito. That's an and so what this will do to me is that is processing fan to the picture. So like this is actually a real mosquito that was trapped in the
So are the sides of that? Is it?
Once it's fully a message will be sent, and the person has to come take it out.
Back, I noticed if maybe I'm just not a skilled mosquito.
Neither was I 5 years.
What kind of visual markers are you using there? Like, what was it to find?
Yeah, very good question. Here. See, for example, for Stephen side, this is the deadliest malaria vector, okay? There's very specific markers in the wings, okay? These are not high quality images, but I have ones. And then Aedes aegypti, the one that's very in Florida, it has a very unique triangle-like shape, white spots on its thorax. The minute you see that, you know it's Aedes aegypti. And I did two pictures for the blood-fed and the non-blood-fed mosquitoes.
What is SOP as soon as we identify a dangerous mosquito?
What is SOP?
Like,
Once they get the data, right, they have models. The public health officials, micrometers, all these models, by looking at temperature, humidity, rain, population, etc., they can quickly forecast how these forecast which counties are likely to be the next hotspots. So those counties can be marked, and then spraying efforts can be focused on those counties. That's the idea. All right. So I next pass it on to my dear Shaun. Okay. Thank you. Sorry if I took a little longer.
I have a bunch of different parts of this talk. I love getting this one to science. Majority talk, so you come back to science. So you see the word AI in there, so that's where your CS stuff is. My research is psychology, theology, philosophy. I know philosophy gets in there, and then computer science sits under kind of the bottom of the engineering and kind of making it work with real-time applications. So I'm not going to show anything cool like that work is absolutely awesome. It's super. I'm going to go the other side of things with emotion and empathy. So you may have heard of emotion. It's out there in the news. It actually gets a lot of crap. A lot of people say that it's not very good. We shouldn't be doing it. Some argument that I could agree with that, but I'll talk about how we do need it. Why it's really important to look at emotion and look at empathy. We talk about God. So the first thing, I have some questions. I'm going to ask you guys questions. We're good at this. What does emotion mean? If I ask any of you, what's emotion? Give me a quick definition.
Having feelings.
Having feelings. Great definition, right? Having feelings. I feel something, right? Anger, fear, sadness, disgust, they're all kind of right? So this is, I'm not going to read this, but that's the Merriam-Webster definition of emotion. So my definition is, it is an internal, like it is something internally that happens, it's some sort of stimulus. That stimulus could be external, like a bear chasing me. I'm probably afraid, I'm surprised, one, that there's a bear chasing me. Or internal, I have a memory, and it happens. It's a stimulus. So what's empathy? Absolutely, yes. The ability to relate to others. I know what it's like to walk in shoes. Right, so this is again the Merriam-Webster definition. So there are three types. There's a reason why I'm giving these definitions in the talk or from the class. So there's cognitive, emotional, and compassionate. So as an example, you're taking my course, come into my office hours, really poorly on this project. There's Sam. Cognitive, empathy, and say, I understand. It's challenging being student. That's it. You're in my office. I'm going to say, oh, I understand. If you're upset or you're sad, I feel that. I am sad or I'm angry or I'm surprised, whatever you are, I feel that with you. This is what you want me to be. Compassion. It's a combination of both of those. I feel what you're telling me. I understand it. I'm going to grade. I'm going to go ahead and I'm going to do something about it. I'm going to rectify that empathy. If you were sad, I am now going to make you happy. So what does it have to do with anything that belongs in this department? So I skipped that. So there's a question. This is on there. So the question, how many emotions are there? So you ask, there are tens of thousands of different emotions. So we started this field, and they said there were 6. They said it was happy, sadness, anger, surprise, disgust, and fear. And that was it. They said everybody feels them. No matter where you're from, who you are, you feel those 6 emotions, you feel them, and you express them the same way. We have that. There are tens of thousands of emotions that people feel in different ways. So our job is to figure those emotions out. Now, so there's that. What is emotion 1? Anybody? What do you think? Just looking at this face. Sadness, that's what I usually get. Anger, right? So sadness and anger. So now, what do you think these are? Joy. Joy. They're both joy. They're both happy, right? She's at some sort of concert. She's happy. Here's a joy. This football player, it looks like he scored a goal. He's super excited he scored that goal, right? So this is what we feed to the AI. This is, I can't do this. I said sadness. It's ridiculously hard, right? How do we get a computer to recognize that this is actually happiness? Right? So that's my job. That's my research. Figure this out. So what this is context. It's important. Right? So right now you might be bored or sitting up here. What is this guy talking about? He talked about emotion. The context is how you're in this room and you're listening to me talk. Right? So your face might show bored. So we're going to talk a bit about how this works. So empathy in healthcare. Right? So healthcare is really, really big right now with this with emotion recognition. A big part of my research is it's in healthcare. Right? So we're going towards this, right? So you see here on the left, there is a human, and there's a robot, some sort of assistant, but let's say in the future, the robot is actually doing the assistant, and there's some back here. They seem kind of upset, right? Just looking at that face, they're kind of looking down, kind of like, well, I'm doing my job. So normal in nature. So, if you had a robot that would actually work out for you, you went into a doctor's office, you was a robot, say I'm a robot, I walk up to you, I'm going to tell you what's wrong with you. Do you think that robot should have empathy? Should it feel something to what you're telling me? I'm getting nods. Yes, absolutely. To me, the answer is 100% yes. That robot should have empathy. I should not just say, okay, you are sick, or cancer, so you're dying. That's it. Right? Get out of here. Right? I'm done. Right? I diagnose you're done. The robot to feel something. And we're pushing towards that. So this might seem like science fiction, but we are doing real work in robotics and real work in empathy and emotion. But here's the bigger question. So, can they have empathy? So we gotta agree they should have empathy. Same with they can have empathy. Anyone, yes or no? What do you think? Yeah.
They pretend to have by being a sad face.
So pretend? Yeah. Good. So that's great. They said pretend. That's it. They could pretend. Right? Doesn't matter. Who? At the end of the day, maybe who cares if it really does have empathy? As long as I think it's empathy, it could certainly pretend to have empathy. As long as I look at that robot and say, oh, you care. Hey, you absolutely care about the situation. Right? So, can we do empathy? Most people already know. Like, real human empathy is impossible to do. It's certainly fake. And maybe at the end of the day, that's good enough. I love this slide. This is my favorite slide in all slide decks that I have put together, is this particular slide. So this is kind of the philosophy part of my research. This is the trolley problem, if you've not seen this before. There are 100 different ways to put this trolley problem. The idea is it's to you. You have the ability to do this. It's travel, it's going to run over 5 people. Run over 1 person. So what do? I ask this on my effective computing course every time, and it's an hour discussion about this particular problem. Anybody, would you pull the switch? To save, you save basically people, so you get 4 people. 1 person dies no matter what, at bare minimum. Would you pull the switch, or would you let it go? I see some money. Yeah, pull the switch. You would or you wouldn't? I would. You would pull the switch. Yeah. No problem. No answer to this question, by the way. It's very much a philosophical and abstract question. Right, so what if, let's say you would pull the switch. What if that's your mother? What if that's your brother? Anybody. What if it's just a dear friend that you know? It's somebody. What if it's somebody in this room, right? You just happen to be there. You have some context with that person. You have some information who that person is. It becomes much harder. Maybe I'm just going to let these people go. Right? That's that question in my class. It divulges into this amazing topic of, first of all, who tied these people to the railroad tracks? Right? They're to blame. Like, whoever originally did that, that's the problem. Why am I standing there? Why is this? Why can't I just stop the trolley? Who is driving the trolley? Can I stop the trolley with AI? It's a great question, right? And it fits into what I'm talking about. Why does it fit? Driving. It is very real. It is everywhere. It's becoming more prevalent. Unfortunately, there are crashes. People die autonomous driving. Right? So that comes to the trolley problem. This is what I consider the modern day trolley problem. It is not a person behind that stick is AI. This is say we're in this say we're in this exact same scenario. This is an autonomous vehicle. This person doesn't exist. This is AI. They can choose to hit these 5 people, or they can choose to hit this one particular person. Right? Empathy. Somehow empathy into this. Some reasoning, some sort of emotion. What to do. Now I'm not saying it's as easy as let's just go one person. Right? It's less people into your situation, having some sort of human response to that. Right? AI. So what Sriram is doing is amazing. Right? You got this awesome computer vision. You want to figure out what the mosquito is. That's highly impactful. Absolutely needed. What I'm talking about is putting humans in. Putting human in the AI. That's what I did. So, right here. So I give this other example. I got this and that one more slides. I'm going to keep you guys for too long. Let's say that we have autonomous vehicles, and outside the fact that they crash, they work. It's me in my car. I'm corresponding with the vehicle. I'm saying, hey, let's go to work. Let's say in the middle of me getting taken to work, I have a heart attack, right? Something happens, something horrible happens. The vehicle recognizes this from emotion recognition. Recognize that there's some medical emergency. I want that vehicle to have empathy and not say, well, you told me to go to work. I'm going to take you to work. Right? So this vehicle is going to drop me off of work and I'm having a heart attack. I don't want that. Right? I want there to be some sort of response, right? I want to understand that my situation has changed. And that part of that is now you can argue with AI if you have a medical emergency, take it. My argument is I need human in that. I need to understand what I'm feeling at that particular moment and respond. That's what we do. So, the very slow. We've got about this more. So, my pitch is emotion necessarily in AI. 100% absolutely. I can argue almost any single case. Maybe some. There's a few. I don't know about. I was thinking. Talk if I can argue that emotion should be in that. But most of the cases of AI, at least when humans are involved, I can argue that you need empathy. You absolutely need it. So, if you go to the news, I encourage you to do this. I encourage you to look up emotion recognition. You're going to see a bunch of really bad things. You're going to see a bunch of people saying that you shouldn't do emotion recognition. It's invasive, biased. Absolutely is. 100% agree with this. I'll look past just recognizing particular emotion. About just putting the human in AI. That's what we do. We want to recognize your emotion. We want to interact with you. We want to do it in a smarter way as a human. So that's what affective computing is. It gets a bad rap because I just know what you're thinking and that's it. Side is a short video. So we need data, right? So Sriram collects the actual species. I don't work with the real data. Well, I do work with real data. In the real world, as far as the species, what we normally do is collected in a lab. Something collected in the real world, but what I'm showing you here is how we collect it in the real world. So this is some work I did many years ago. I'll actually turn the video here. Hopefully the audio is working. I think it is. It's kind of low, but there is on. So what we're doing, up in the top left, you're collecting 3D data, collecting thermal data. This is heart rate and physiological. These are all the kind of things we look at. Don't just look at dates. But this is, I love this guy. We forced him to sing. This one, he does not want to sing. This is thermal information. So when he starts to rise, his whole body, he's embarrassed. He does not want to be there. So there's 4 of us sitting around this guy, and he said, song, right? So it worked. Our purpose would elicit embarrassment, and the guy definitely got embarrassed. So physical pain, very hard to get real pain. So just from the human rights aspect, we can't go poke people and so what they do is shelter pain in a bucket of ice water for some extended period of time. It gives maybe at least discomfort, pain, but that's as close as we can get to real pain outside of the hospital. To get real pain, they go into hospitals and collect different pains that are in the ER or some procedure. So this is more the CS type study, some of the features. So I love this. So this is the session right there. So what that was we had this bottle, and what took the bottle out was dead fish. So it stunk. It was disgusting. It was horrible. I don't recommend it because it stunk. pretty much 6 months straight. It was absolutely awful. Down the hall, everybody's complaining, but we got really good data. So there's another way to do this, and you'll be good to go. Yeah, this is just some feature tracking that we do there. So that's it from my talk. If anyone has any questions, I'd be more than happy. Yes, please.
Okay, so one question that I have is that if you were to use this in the medical field, I feel like would you try to make robots look like themselves? If it's difficult to have a robot give a human empathy, and I'm kind of looking at it and it's like I know it.
Yeah.
It's not. It's a robot.
It's a robot. Yeah. So I love that question, and that's a phenomenal question. Thank you. So the answer is it depends, right? So there's a problem with the uncanny valley. It's called. So basically, you have this idea where the robots start to look human, but they don't, right? So something's off. Right? They kind of look human, but I'm looking at that. So ultimately, the answer to that question is, yeah, I'd love to. Right? We would love to have this humanoid robot. You don't know, right? So it's just like a perfect simulation of me standing up here and walking. That's what we want, right? It's unbelievably challenging. Today, it looks like a screen. Right? It looks like a robot. It looks, and half the time, they don't even work. Right? This is where we want it to be. The robot gets caught up, right? It's like, how are you doing? You answer it, and it says, I went outside today. That's it's really challenging. It's a challenging problem to communicate in real time with a robot. Besides for the look. So yeah, that's a very active research area. Absolutely. Someone else? No? Oh, you do? Yeah, cool. Thank you.
So what is the average cost of production?
It's a good question. Depends on what it is. This data collection, it costs maybe $500,000 to collect that data with the sensors and the cameras we got for robotics and real world stuff. You know, more for right. If you want it real, it's really get you well with $1 million. But I can come in here with some, as Sriram was talking about, kind of scan you people, and I can make it work to some degree. It might not be accurate, but I can get some from you as simple as a cell phone. Yeah. And to that question, one last note. So that makes it impossible for people to do, right, in the real world. I can't say, hey, give me $1 million and I'll make your awesome home. Part of our job is also bring down costs and to make everything works in a camera really well. Anyone else? I think I took up Shaun, but I will definitely keep answering questions. I talk about this all day.
The application of this for like autonomous vehicles be like being a balancing act between what would be considered appropriate amount of damage? Because I know a few years ago Mercedes-Benz came out and said their autonomous cars in the future are going to primarily focus on the safety of the driver rather than the safety of the people or the things around it. So would it just be trying to find that fine line between keeping the person safe in the vehicle and the people outside of it?
Yeah. So first, I'd like to respond to that. I didn't hear that, and that's terrifying to me. I'm not saying don't prioritize the safety of the person, but to completely prioritize it over the walking, to me, is not the way to do it. But to that point, yeah, there's some sort of act of. I'm talking about fully autonomous. A person can drive the car, semi-autonomous. There's not as much. With the person and see outside of it. So ultimately, what the human aspect comes from is how would I respond? Right? How would I respond in a situation? How do you can we respond similarly? But can we actually do it a little bit better? We don't want to just make an emotion. We use it in a positive way, right? So road rage, I don't want the car to have road rage, right? I don't want anger to be an emotion or an empathy that the car gets from. So yeah, it's a absolutely. Anyone else?
For people to try and take advantage of or exploit weaknesses in AI?
Yeah, that's an awesome question, and it's huge, right? So just in the general sense, people can exploit AI in any way they wanted to. So I told you just specifically with the emotion, you'll see this in the news. People use this to decide who's going to get hired, right, for a job. So you're sitting there, you make the wrong facial expression, the wrong movement, rejects you and you're not a hireable person. That's a way to exploit AI. I can exploit you. I can hire you based on your race, age, or your gender. Right? So these systems can be exploited to do that. The cost or the chance to exploit it is very high. It's our job as researchers and scientists to be ethical, right? To not allow it to be exploited. We always do it. That's amazing. I could talk about it for literally weeks. That's my core philosophy is the ethics, how to stop the exploitation of AI. But yeah, there's a lot of ways to do it. If you're interested, definitely come talk to me. I love that topic. Absolutely. I think I gotta let the next person. I will talk after it. Like I said, I could talk about this for days and weeks. I love this stuff. We saved the last. Sade's gonna talk about work.
I think I may have to stay behind. I don't think this will. May have some motion here. Okay. I'm Sayde. I'm a PhD student and joins an engineering department, and I'm a member of Cyber Identity and Behavior Research Lab. Dr. was our lab director, but she's not available. So to begin, we're just going to have a brief overview of some of the topics that we investigate in the lab. As you can see, three main topics kind of going. User authentication, natural language processing, which is like using text to learn different things about using AI. And behavior recognition, which kind of floats along the same lines as Dr. Canavan, but it's a little bit different because we're not fully focused on emotion. We're interested in like behavior and what things is wrong. So if you're interested, I'm on the behavior recognition thrust, deception detection thrust, mental health. So this is just like an application. But basically everything that you see here, there's someone in the lab investigating it. I'm just wonky. So something that Dr. is really passionate about to discuss is user authentication. That was her bread and butter when she was a PhD student. So we're pretty familiar with authentication. Everybody has words to get into things. So that's knowledge-based. There's also token-based. So I'm not sure if your banks have ever had this, but sometimes they have different images, and then you have to pick the image that's your image, that's your token, that's you. And then there's biometrics, so Face ID, thumbprint, things that we're really familiar with. Not just here. Okay. So for knowledge-based, like more passwords, generally, problem knowledge base is there's a lot of cognitive load on the user, right? You have to remember your password. 10 million accounts, there has to be a different password for every account, right? If you're doing safe cybersecurity practices, which we hope USF IT definitely encourages it, right? So here are some of the most common passwords. If they're bad passwords, don't use them. But this is just to show this is one method of authenticating a person. Token user authentication is another method. I kind of described the example with the bank, but there's also like physical tokens. So for example, if you're doing like government work, you have a government laptop, you may have your government ID that you need to be able to actually access your computer and things like that. So the problem again with token-based authentication is that you still have to remember. In this case, physically it would be remembering to have your ID. You can get access to your computer. And so that's basically what this is describing. Specifically for mobile device authentication, I mean, it's complicated. You have to remember something, so there's still some cognitive burden on the user. Then there's authentication, it's a little bit easier. You know, you use what you have, your face, your voice, your thumbprint. So this, if you're pretty familiar with this, it definitely reduces the memory load of the user. So that's great. It's convenient. It's awesome. Skin, that's something I just remembered. Which is all good stuff, but there's a way to improve it. And so a way to improve could be by doing continuously without having to actually put your finger there to have it scanned, or without having to make sure you're in a room. So something that you kind of start to think about when you think a little bit more about authentication is it good for everybody? Like, the methods we have now that work for all people. And so this kind of became more relevant, especially during the pandemic. Kids were at home doing remote learning. Like kids of all ages, right? They were really young kids who suddenly needed to be able to get into laptops to log on for class, things like that. So basically it becomes important for users to be able, of all ages, to be able to interact and gain authentication and access these personal computing devices, be it laptops, desktops. We know kids love their iPads, all that kind of stuff. And so the thing is that based on your age, you know, for example, say a kid's on an iPad, you know, I'm sure the mom probably has banking information, things like that on there. The kid doesn't care if they're watching Cocomelon, right? So if they walk away from Cocomelon, you know, that iPad has information on there that is useful and can be exploited when it presents a security and privacy. So the question was, do authentication systems support the everyday user or every user? And the answer to that question is no, really. So for kids, that's kind of one of the main focal points, because elementary age children typically rely on their parents to make passwords for them. So that's not really catering to kids, right? May not be a password that's natural for them. On the flip side, they may pick a password that's natural for them, but maybe the kid's name is and their password is null, because that's something that's easy for them to remember. So the goal is to kind of figure out something that works for kids, that's useful for them, that actually is just useful across all ages, but you know, kids are definitely in the conversation. Right? And so we have here just a little bit of some things that to consider, right? With text-based authentication, I mentioned the passwords. You know, the processing power, brain size, a little different from that of an adult, right? So that's also something to consider. And then on the last bullet, we have stuff regarding biometric differences. So my thumbprint, my ridges may be more deeper ridges and valleys in my thumbprint than that of a toddler. Maybe it's smoother. Right, so these are all factors that we have to overcome to perform successful authentication. And so this is work that's currently being done. We're currently doing collection, and we are trying to gather data and collect data across various age groups. Through people 90. To learn more and develop authentication systems that are useful across age ranges, that works effectively across age ranges. And so here we have just a bullet on some of the things that we're interested in. And so here we have some of our research questions. How do individuals perceive and use and perceive authentication methods? What are positions and concerns for the use of continuous authentication? Behavioral and physiological modalities enable age-aware authentication. And so you can see on the right-hand side here, we have a diagram. So we have our user here, and this is some personal computing device, could be a phone. For this example, it's a desktop computer. And so what we're doing in the lab is we're extracting things to be leveraged as authenticators, things like how quickly you type, maybe the pressure with which you hit the keys as you're typing. Touch dynamics on the phone, literally just like how you interact with your device. And mouse dynamics, sometimes these things are really different for people, and so it can be leveraged. Maybe some different pieces all together can be leveraged, to authenticate. A little bit more on the work that's on the lab. So Dr. Canavan actually probably knows images more so than I do. I'm not an object. But this is a collaborative effort. The project that I've been talking about is a collaborative effort with folks at the Events Lab and also with folks at USF. So the labs are listed there. The Ruby's Computer Interaction Lab, Intelligent Natural Interaction Technology Lab. And so the UF folks are more interested in mental models. That I mentioned here. A mental model is just like how people understand something. So we have a mental model of how the world works. The mental models that people have with respect to authentication. So this is our shameless plug for you guys to sign up if you would like to help us out with our data collection. This is just a small example or a couple of pictures of what our labs look like. This is an undergrad, an undergrad RU, Dr. Sarkar RU. They're awesome. His name is Nick. He's cool. Basically, we were using and we're also collecting physiological, behavioral data from a worn wearable device. So the idea is kind of use all these different data inputs to learn more about continuous authentication and to be able to authenticate someone. So this is, I see no one's taking this, but that's okay. This is the link. This is the link to learn more and to get involved and help us out and participate in our research study. Just gonna slowly scroll.
Just a little bit.
A little bit slower. Just creepily sly. Oh, thank you guys. I appreciate it. Tell your friends. Ages 6 through 9, whoever you know. And so the lab, one of the thrusts that I mentioned. Oh, I see more. Yeah. So you guys are helping me out a lot. Thank you. Or one of our research thrusts is natural language processing. So in the natural language processing group. And so here's another link for you to go and learn more about other research labs and departments that are interested in natural language processing. Have that at one of the front of their research thrusts. And so this is not a plug for the research study, but just to generally get involved with this type of research. So there are opportunities to get involved with our research lab through independent study with Dr. Neal. So those are course codes to sign up. If you're a research, if you're a master's thesis opportunities, if you're a PhD student, that way as well. And then lastly, as a research participant. So yeah, here's a picture of our lab. This is Nick from before, who I mentioned. There's some members of our lab. That's Neil, who's not here. That's me. And she's actually a member of the Events Lab. These are great people who fund our work. And that's it. And so this is our contact info. If you have questions about that research study that I mentioned, you can email us. That's the link to our lab website, and we're located in 50. So that's this building. That's the hallway. Thank you.
All right. With us, we have one presentation from one of our esteemed faculty members. I also have our success coach here, who is going to introduce us. Remember, we still going on for you, so there are pizza and t-shirts, so there's a good
Yeah, go, perfect opportunity to grab pizza. Go.
Yeah, there's pepperoni and cheese, and there's vegetarian in the back. But yeah, I don't want you to leave. Yeah, I'm like. Are you ready?
Yep.
Okay, so if your pizza, just so for time's sake, if everybody can have a seat, yeah, we'll have you for a few more minutes. And on your way out, you can get your okay? Thank you so much for your patience and participation.
Okay. Hi, everybody. I am Dr. Shaun Licato. I run the Advancing Machine and Human. How many of you have messed with GPT-3 before? Anybody? You ever talked to a computer before? Okay, I need volunteer. You're standing up.
I believe it.
Ask a question.
So for your lab, just out of curiosity, I saw like you were accepting like graduates for your research. But how inclusive are you for like varying degrees of experience in comp sci?
I'll use very.
Yeah.
So, expertise?
Yeah.
All right, let's see what the GPT-3 says. I'm very inclusive, varying degrees of experience. I think it's important so I'm growing in the field of That's actually. One more. Any questions? You get to ask the most advanced natural language processing bot currently available. Any question you
Can
want?
we do like a train question? If the train leaves the station at 15, how many miles an hour? There you go, 50 miles an hour. I don't know. There you go. Yeah. You got it.
When will it reach?
San Francisco.
Let's see.
Oh.
I guess it's math. That's not fair.
How does it do that? Is that magic? A little guy who decided they could just type really fast. You remember Mechanical Turk, the original? Right? In the 1800s, this guy had a box, and he said it was a computer that could play chess, and he could play chess against it, and they would lose, right? Turns out it's a guy under moving magnets. That's where it comes from. But as we know, computers can destroy us in chess, and they can beat us in Jeopardy, and in life, they'll be able to beat us in language games as well. How do we get to that point? Natural language processing, everybody. That's NLP. My lab, we focus on the connection between NLP and human reasoning. And so I want to just briefly go through a couple of the strands of research that we've been working on for years. One of them is inference-based NLP. Okay, so if you have two sentences, how do you determine whether they mean the same thing? One of the theories we have is that they have different, what we call inference, right? So from this sentence, you can infer the man has 2 feet, probably, because he probably has 2 feet, right? If the man was running, that means there is a person who was moving, right? If you look at the sentence, the man was sauntering, then you can infer a lot of the same things you can infer from that sentence, but you can also infer that he was not trying to get somewhere that contradicts that, right? So if we were able to theoretically get all the sentences that these two infer or non-infer, we compare them, and that's how we find out whether two sentences mean the same thing. How do you do it automatically? A lot of computational power. In fact, NLP is so resource heavy that Facebook is trying to, there's not enough GPUs on Earth to do the projects that we want to do right? That's how much computational power. Psycholinguistics is a field that tries to measure human intelligence, different cognitive abilities, and we showed that you can actually use the language models like GPT-3, I showed you, the thing that generated that crazy text, right? To actually predict how individuals, how human beings, will respond to certain tests of intelligence. Individuals. I can take one specific person, study how you reason, and see how it differs from other people. This connects with code projects that we're on. One of them is Dr. Canavan's a guy on as well. Another one is arguments analysis. I really love debating with people. Anybody? Love getting in fights. It's kind of fun, right? But more importantly, it's how we decide things as a society, right? If there's something controversial, if there's something two people disagree on, we use argumentation to communicate with each other, to reach consensus, right? How do you get computers to do that? Well, I don't have enough time to show you, but the short answer is natural language processing again. Then I want to quickly go through this last newest area of research that we're doing with the Air Force Research Lab. They're really interested in wargaming. Some of you may have seen Europa Universalis 4, Civilization 6, game that, right? How do they know how to play it? They are really awful at playing it, especially if they have to negotiate with you. If you ever played that and they try to offer you a deal, that's just awful, right? There's a reason for that. State-of-the-art AI in negotiation is bad. Even though I showed you, GPT-3 does amazing at generating text, the kind of reason you need to do for realistic negotiation with other human beings in games like this is really bad. And then we played this other game called Next War that had a rulebook that was about 100 pages long. About a week to just learn how to play. Imagine getting an AI to play that game, right? And another thing that we are diving into is collectible card games. Magic the Gathering, Yu-Gi-Oh! Is that one of them? Right? Yeah. There's an NLP problem here because this is arbitrary. You can have almost any text you want here, right? How do you get an AI to understand that? The answer is it's tremendously complicated because you can have anything you want. So you can have a card that says, when you play this card, another card can say anything you want to say. Something like that, right? That's theoretically a possible effect. How can you even reason over something that complex? So you can actually change the game while you're playing. It's crazy, but someone's got to do it. So that's what we do. Okay, so get involved. I got some undergrads who are working on this project in particular as independent studies. So that's the kind of thing you do typically after you take structures.
Yeah, the other structures.
So, okay. All right. Thank you very much.
I hope you learned a lot. Hi, everyone. Good evening. My name is Jasmine Jones. I'm a success coach here at USF, specifically for CS graduate students. So thank you for coming out today and participating in our week of welcome. We welcome each and every one of you. For many of you, probably this is your first semester. It's my first semester as well. And so I look forward to working with each and every one of you. Know that on your journey here at USF, right? As life may sometimes throw at us, when we may come across certain bumps and challenge obstacles, and know that as your success coach, I would like to see you be successful with your time here at USF and make the finish line. So welcome, and use this time if anyone has any questions to wrap up, and if a few of you wouldn't mind staying behind for a group photo that the department chair